Si el hombre no aprende a tratar los océanos y la lluvia forestal con respeto, se extinguirá. Peter Brensheff. Buenos días. Doctora Alison Dagan, directora académica de School of International Training. Magíster Juan González, decano de la Facultad de Ciencias y Tecnología. Magistra Orosia de Poveda, vicedecana académica de la Facultad de Ciencias y Tecnología. Magistra Amanda Watson, coordinadora de la carrera de Ingeniería Forestal. Doctor Edith Manzané, profesor de la carrera de Ingeniería Forestal. Autoridades, invitados especiales, jóvenes estudiantes, señoras y señores. La Universidad Tecnológica de Panamá, a través de la Facultad de Ciencias y Tecnología, se complace en presentar en el Simposio de Divulgación Científica los hallazgos que, a través del estudio de los ecosistemas marinos y conservación de la biodiversidad, fueron realizados por la School International Training en la República de Panamá del 24 de enero al 10 de mayo del 2022 con el auspicio de la Embajada de los Estados Unidos. En este curso interdisciplinario, los estudiantes tuvieron la oportunidad de conocer, trabajar y hacer investigaciones en diferentes tipos de ecosistemas en la República de Panamá, además de interactuar con los pobladores locales, logrando de esta manera una perspectiva integral de los problemas de conservación, tanto desde el punto de vista de la ciencia, la ingeniería y la perspectiva humana. Seguidamente, la doctora Alison Dagan, directora académica del CIT, se dirigirá a la audiencia. Doctora.
Muchas gracias. Muy buenos días. Muy buenos días a todas y todos. Apreciadas y apreciados colegas de toda la Facultad de Ciencias y Tecnología. Queridos estudiantes, muy buenos días. Me da mucha alegría estar aquí hoy. Esto ha sido un sueño nuestro por muchísimos años. CIT Worldwide cumple 90 años este año y CIT Panamá este año cumple 20 años. Hemos recibido muchísimos estudiantes, gracias a Dios. Los estudiantes que tenemos aquí hoy han escogido a Panamá entre muchísimos países de que pueden haber escogido de venir a estudiar la hermosa fauna y flora de Panamá. Hablo en nombre no solamente de CIT, pero de muchísimas personas que nos ayudan y nos han ayudado a través de estos 20 años y a lo largo de este semestre que llevamos ya 4 meses juntos. Entonces, quiero dar las gracias a todas estas personas, aunque no estén aquí, también al personal de CIT que están aquí. Y quiero también expresar lo hermoso que ha sido esta oportunidad de integrar jóvenes de Panamá y de Estados Unidos. Siento que ha sido un semestre único en lo personal para mí. Estoy aquí en Panamá, en el CIT, hace 20 años, y este ha sido el más especial que he experimentado. Con nuestros 20 años y los 90 años de CIT Global, nos demuestra lo que es la perseverancia, porque perseverar durante 90 años y 20 años nosotros, entre las vacas flacas y las gordas, es un mensaje. Pero un mensaje para mí más grande ha sido presenciar la perseverancia de los 12 estudiantes panameños y panameñas que nos ha acompañado y nos han integrado durante todo este periodo. Nos han mostrado tenacidad, nos han mostrado convicción, nos han mostrado alegría, nos han mostrado pasión por su país. Y nos han mostrado otra cosa. Nosotros sabemos, quienes estudiamos esto, los que estudiamos esto, colegas, estudiantes, sabemos que no es para ganar dinero, ni poder, ni fama. Estudiamos esto porque tenemos una pasión por un mundo verde y un mundo azul. Y presenciamos en estos 4 meses que esa pasión trasciende idioma, trasciende cultura, trasciende edad. Y eso ha sido, en lo personal, y creo que para todo el personal, extraordinario. Entonces quiero pedir a Luis, a Josué, donde está Katy, Casey, Vero, Ronald, Rafa, Fernán, Siad, y si no te nombré, los 12, por favor, si se pongan de pie. Luis, perdón, todos, Brenda, Ani. Tenemos 12 muchachos que fueron escogidos de más de 70 aplicantes que han tenido que luchar y pelear por estar donde están. Y les quiero felicitar con todo el alma. Así que, gracias. Finalmente, para no alargar, quiero agradecer a la profesora, al decano, al doctor, por todos sus esfuerzos, la coordinadora, a la tecnológica en general, por acompañarnos en este proceso y darnos esta oportunidad. Muchísimas gracias.
Tenemos que construir una sociedad más amable, más humana, más lenta y más conectada con el mundo natural. Heiken Freire. Cabe destacar que este programa se ha llevado a cabo por más de 20 años en la República de Panamá, pero este año, gracias a los fondos proporcionados por la Embajada de los Estados Unidos y la colaboración de la Facultad de Ciencias y Tecnología de la Universidad de Panamá, 12 estudiantes que acabamos de conocer participaron activamente, de los cuales nos sentimos muy orgullosos que 7 de estos chicos son de nuestra carrera de la ingeniería forestal, lo que representa un hito importante en la vida académica de estos estudiantes y en el fortalecimiento de sus capacidades individuales. En la mañana de hoy, el magíster Juan González, decano de la Facultad de Ciencias y Tecnología, dirigirá unas palabras en representación de nuestras autoridades de la Universidad Tecnológica de Panamá.
Muy buenos días, doctora Alison Dagán, directora académica del CITE en Panamá, al doctor Eric Manzané, que es el enlace académico por la Universidad Tecnológica, la profesora Orosia Poveda, que es la vicedecana académica de la Facultad de Ciencias y Tecnología, la profesora Amanda Watson, coordinadora de la carrera de Ingeniería Forestal, la profesora Blanca Sánchez, que es la jefa del Departamento de Ciencias Naturales. Las autoridades de la Facultad de Ciencias y Tecnología nos sentimos comprometidos con los procesos de enseñanza de nuestros estudiantes, por lo que siempre estamos anuentes a que los mismos participen y adquieran experiencias en su campo laboral. Es por ello que con orgullo la información del doctor Eric Manzané, que un grupo de 7 estudiantes de la carrera de Ingeniería Forestal habían sido seleccionados para participar en el curso de 4 meses de duración titulado Panamá, Ecología Tropical, Ecosistemas Marinos y Conservación de la Biodiversidad, dictado por el School of International Training. Estos estudiantes tuvieron la oportunidad de conocer y trabajar en equipo, hacer investigaciones en diferentes áreas de la región o de nuestra República de Panamá, donde adquirieron mucha experiencia y complementaron muchos de los conocimientos aprendidos teóricamente en las aulas de clase, aunque muchos de manera virtual, ¿verdad? Este curso se llevó a cabo del 24 de enero al 10 de mayo del presente año. Los estudiantes seleccionados para este curso por la Universidad Tecnológica de Panamá fueron Josué Santos, Verónica Díaz, Luis Felipe Bustamante, Fernando Araúz, Yulisa Guevara, Casey Flower, Caterine Herrera. Así que estos estudiantes particularmente son de la carrera de Ingeniería Forestal de la Facultad de Ciencias y Tecnología. La verdad es que nos sentimos tan orgullosos como ustedes de lo que aprendieron en estos 4 meses. Como dijo la profesora, un curso interdisciplinario que se centra en los diversos ecosistemas terrestres y marinos de los trópicos y su conservación. Inmersos en ecosistemas mismos, los estudiantes estudian la biología, la ecología de estos entornos frágiles y examinan el impacto de la actividad humana en el medio ambiente y las formas en que las prácticas de conservación pueden servir a los intereses humanos y ambientales. Los módulos desarrollados contienen componentes específicos que le permiten a los estudiantes lograr una mejor comprensión de los diversos aspectos de la biodiversidad, conservación y la interacción de estos con los seres humanos. Para culminar el curso, ¿verdad?, cada uno de ustedes tuvo que presentar un proyecto de investigación, que es la actividad que nos ocupa en el día de hoy y los 2 días restantes, ¿verdad? Estas investigaciones eran hechas de forma independiente, donde ustedes pondrían en práctica los conocimientos adquiridos en este curso, desarrollando la investigación desde las fases iniciales por su propia cuenta. En estos 3 días, ¿verdad?, se está llevando a cabo por más de 20 años, como dijo la doctora, pues esta actividad, y gracias pues a los fondos otorgados por la Embajada de Estados Unidos, pues logramos nosotros pues que 12 estudiantes panameños participaran de este programa. Queremos felicitar a los estudiantes, a todos los estudiantes, a los panameños, los de Estados Unidos, pues que tuvieron esta oportunidad, y estamos convencidos de que esta experiencia los nutre de conocimientos y contribuye al mejoramiento y conservación de la calidad de la enseñanza y la investigación. Agradecimiento especial también nuevamente a la Embajada de los Estados Unidos por el apoyo, al doctor Eric Manzané y a los profesores de la Facultad de Ciencias y Tecnología, pues que le han dado todo el apoyo, y como siempre decimos a nuestros estudiantes que la Facultad de Ciencias y Tecnología es una facultad para todos. Así que muchas gracias y que tengan un excelente día.
Si sirves a la naturaleza, ella te servirá a ti. Confucio. En la mañana de hoy también queremos presentarle a nuestra vicedecana académica, la magistra Orosia de Poveda, quien, aprovechando la oportunidad, se dirigirá a los presentes en el idioma inglés.
Good morning. Oh, sounds familiar, right? Okay, well, I exactly know how you feel. Okay, well, you know, these are going to be very brief. We really want to express our deep appreciation, for you being here. Thank you to Dr. Allison, Dr. Manzané, Professor Amanda Watson, Professor Blanca Sanchez, and our dean. We just can't express our deep appreciation for all the SIT effort in making this a dream come true. We hope that you are able now to manage some Spanish, those of you, right? Okay, very good. So I'm glad, and I hope the people from Panama are able to manage some English by now. So that we really are happy. We want this program to come back, and we just want you to have fun with your presentations. So have a great day.
La Facultad de Ciencia y Tecnología espera seguir fortaleciendo los lazos de cooperación con la School International Training hacia el futuro. De inmediato, lo dejamos en compañía del PhD Eric Manzanet, profesor de la carrera de Ingeniería Forestal y Enlace Académico. Bienvenidos todos y tengan un excelente día.
Ante todo, buenos días. Yo quiero primero que todo agradecer la oportunidad que se me ha dado y decir que muchas veces se nos dice que las cosas pasan por suerte. Muchachos, las cosas no pasan por suerte. Hay que estar preparado para aprovechar la oportunidad. Esta oportunidad se dio en este momento preciso que yo iba entrando a la carrera. La profesora Ali me contactó y me dice, ¿podemos contactar con alguien en la carrera? Yo dije, sí, podemos contactar con la profesora Blanca. Y ahí empezamos a hacer esto. Era algo que no se había hecho antes, pero que si la oportunidad se dio, había que aprovecharla. Teníamos que estar preparados para aprovecharlas porque no sabía cuánto se iba a dar. Y ese es el mensaje que les mando a ustedes. Ustedes son los que van a seguir con esta lucha que hemos llevado durante mucho tiempo todos de conservar el ambiente. El mensaje de nosotros hacia ustedes es que ustedes son la esperanza de que realmente las cosas cambien, de que el paradigma forestal de que hay que extraer cambie a que hay que conservar, de que los bosques, de que los mares, de que las cosas que estamos aquí en este mundo no son solamente para explotarlas, sino para conservarlas. Nosotros hemos estado aquí, espero que hayan tomado este mensaje que le hemos dado, no solamente nosotros, sino todos los otros profesores de la carrera. Gracias de nuevo a la profesora Blanca, a la profesora Amanda, al decano, a la vicedecana, porque sin la colaboración de ustedes no hubiéramos podido llevar a cabo toda esta magnífica experiencia que hemos tenido, que los estudiantes panameños, tanto la nacional como la tecnológica, sé que van a recordar que los estudiantes from USA, you're gonna take this experience with you pretty much forever. Entonces espero que esto sea algo una semilla que hemos plantado ahora y que siga creciendo, que todo el tiempo podamos mantener esta buena relación que hay entre los dos programas para que cada vez más estudiantes puedan pertenecer y pasar por esta experiencia, que es una experiencia integral, porque no puedo ser un biólogo y solamente decir, estudio plantas, pero no me interesa qué pasa con los seres humanos, o no puedo ser un ingeniero forestal, o no puedo ser un científico de las ciencias sociales sin saber qué pasa con el otro lado. La ciencia debe ser algo totalmente integral. Por eso este programa es tan importante, porque nos ayuda a tener una visión mucho más completa. Así que por el día de hoy, sé que vamos a empezar con sus presentaciones y estoy seguro de que todos han hecho un excelente trabajo. Muchas gracias y empecemos con esto.
Te doy la señal. I'm going to give you the signal to begin.
Gracias. Jesus. Hi. Buenos dias. I am Lake Barrett. I'm here from the College of Worcester in Worcester, Ohio. I'm going to be presenting in English today. And for my project, I took a trip over to Bocas del Toro to look into comparing amphibian species diversity and abundance in natural forest and cacao agroforest, specifically at Finca La Magnita, Bocas del Toro in Panama. And so what we're going to go through here today is a brief introduction to the research topic, why it's necessary, go over the study site and methods, and then look through our results as well. And to start, this is a project driven in biodiversity conservation, specifically in amphibians, with whom biodiversity loss has been felt greatest. And that's particularly important because they're an integral part of ecosystems worldwide. They're both predator and prey, and ecosystems can collapse when they start to disappear. So it's been well studied, and the main culprit for amphibian biodiversity loss is Catridiomycosis, which is a fungal disease responsible for killing at least 501 amphibian species worldwide and causing their general declines as well. The effect has been felt mostly in Australia and Central and South America, but it's still a worldwide problem. And Panama is no exception, particularly being in one of the most hardest hit areas. It's definitely had an effect here. Catridiomycosis spread eastward through Costa Rica and through Panama, and it's left decimated amphibian populations in the country. And so most of the research in Panama on amphibians looks at how Catridiomycosis has affected them and their populations. However, because Catridiomycosis is the main culprit, it gets lots of attention when it comes to amphibian biodiversity declines, but it's not the only factor. Another one is agriculture, which is currently the most prominent cause of biodiversity loss on the planet, looking at all species in all places of the world. I believe the micro, is it? It's growing. The human population is growing, and with it, demand for agriculture, so it's expanding and only increasing the amount of biodiversity that it is destroying. And because of that, it's particularly concerning. The effect would be felt most in the tropics, where there is A, the most biodiversity to be lost, and B, the largest projected population growth. So that is particularly concerning considering the amount of biodiversity that's in the tropics. And generally, because of the concern of agriculture growing and expanding, lots of effort has been put into how do we conserve biodiversity while accommodating this need for agriculture. And one prominent idea for that is agroforestry, which is the retention of trees, canopy cover, or elements of the forest on land that's used for agriculture, typically for crops like coffee or cacao, which grow under the shade of the canopy. And these forests can retain up to 60% of the biodiversity of a natural forest. And that's been shown in birds, insects, certain mammals, and some reptiles as well. However, and importantly, how these agroforests affect amphibians is pretty unknown. It's very under-researched, and because of that, there's no consensus on how effective they are for the conservation of amphibians. Some studies in Colombia, Costa Rica, and Indonesia found decreased diversity and abundance in the agroforests, which suggests that they can't use this environment, but others in Colombia and Mexico demonstrated that they can retain a significant amount of amphibians and that they can use this environment. So there's generally not a consensus here. And one probable reason for that is regional effects. There are lots of different ecosystems and lots of different parts of the tropics throughout the world, and each could respond differently to agroforests as a solution for conservation. And because of that, it's so important that this has been researched here in Panama, not at all. And it's why I sought out to investigate this to understand better how it could be used here where there have been critical amphibian declines. So to do that, I went out to Finca La Magnita in Changuinola, Bocas del Toro, which is an amazing farm. I can't speak highly enough about it. They do awesome work there. It's 42 hectares, borders the Rio Toribe. It has cacao agroforest and natural forest, and there's also some pasture land. They grow all kinds of fruits in their garden. It's an amazing place. And it's also an amazing place to do this study because the natural forest and the agroforest are within close proximity to each other, which A, makes it logistically easy to do the study, but it also makes it so that I know that the effects that I'm measuring are due to the management style and not due to small geographic effects. Here we can see a map of Finca La Magnita. In the top, your right, you can see Changuinola, and to either side of it, extensive banana plantations. That is the threat that agriculture poses, specifically in Bocas del Toro, the expansion of those plantations. Way off to the left would be Pila, where you can see the forest starts to get thicker. And zoomed in on the farm, you can see the outline in red. I'm not sure how well it shows up on the presentation. It's the section to the right. That is the agroforest. It's much more accessible, and because of that, much more accessed, obviously. And then to the left, you have natural forest, which is kept purely for ecosystem services and conservation value within the farm. And that would be to the left. It's a little bit more hilly in that area as well. So the methods I used for this project were transects, and specifically linear transect sampling in order to survey the amphibian populations of the area. And that involves creating a linear transect, marking every 10 meters, and counting all amphibians within 2 meters and under 2 meters of your transect line. I created 20 transects in the natural forest and 20 transects in the agroforest to compare. And in the agroforest, they were random. But in the natural forest, it's more difficult to traverse, it's more sloped, and the transects had to be placed where we could access them and where we could fit them. So in the natural forest, they were not random. Each transect was run once during the day and once at night, and then the observations were lumped together into one transect. So each transect includes the night and day observations. Typically, day observations were early in the morning, and night observations were right after nightfall, around 7:30. While running the transects, each amphibian was recorded, including the meter mark it was found and the time it was found, and then photographed if necessary. In the photo, you can see an Uuphaga pumilio. They are quite distinctive, and I know them very well. I don't need to take a photo of every one of those I see. I would have been left with over 100 photos of Uuphaga pumilio. So photos were saved for the frogs that needed specific identification, mainly our Craugastor species. And in those cases, I used amphibians of Central America and amphibians of Costa Rica to identify them. While running throughout all the transects, we made an effort to disturb the amphibians as little as possible and not trample the forest. Particularly at night, when in bright light, we made a real effort not to expose the amphibians for very long at all, as short as possible. And once all the transects were run, the Shannon-Winder index value, species evenness value, richness, and abundance were calculated for each transect, and then averaged to be able to compare between the agroforest and the natural forest and tell whether or not there is a significant difference here. And boy, was there. You can see here, mean Shannon diversity index value per transect between the natural forest and agroforest is significantly higher in the natural forest, and there's a significant drop-off in the agroforest. And we can see the same thing in mean species evenness. There's a significant drop-off from agroforest, from natural forest to the agroforest. And then when we look at mean species richness, we can see the same phenomenon. We see natural forest significantly higher than agroforest, meaning that the natural forest measured higher in every diversity index there was. Moving on to abundance, we see the greatest difference. In total, there were 156 observations in the natural forest. There were 30 observations in the agroforest. So there were way, way more frogs in the natural forest, and that's represented here in the average amphibians per transect measurement. And now we're going to move on to look at species patterns. These are the amphibians that were observed in the agroforest. We can see there are 8 species observed here. I'd like to point out Dendrobates auratus, Pristomantis ridens, and Smelisca sordida. Those species were only found in the agroforest, which in one case is interesting. For Pristomantis ridens and Smelisca sordida, they were only observed one time, so there's not sufficient evidence to say they have a preference for the agroforest. But for Dendrobates auratus, there is, because it was found 8 times in the agroforest and it was never found in the natural forest, suggesting that it has a preference for that environment. Also, as we transition to part B of this figure, I'd like to point out the size of the y-axis here, the scale, and Craugastor bransfordi, Crassidigius, and Fitzingeri. Point those out as we transition, because Craugastor, Crassidigius, Fitzingeri, and bransfordi are all found in relatively similar amounts between the agroforest and the natural forest, suggesting that they may not have a preference for between the two environments. Also, right away, you can see the significant increase in the size of the y-axis as a result of the change in number of observations. I would also point out here that Uophagopumilio has a significant preference for the natural forest, even though it was found once in the agroforest. And there are 5 species that were only found in the natural forest, those being Alobates talamancae, Silverstonia flotator, Rabo hematiticus, Craugastor gomeri, and Pristomantis gagei. Those were only found in the natural forest, and in most cases that suggests that they have a preference for that environment, or in some cases maybe just are unable to use the agroforest as an environment. So moving on to discuss some of the points from this. Obviously, the first one is that the results demonstrate that diversity, evenness, richness, and abundance is all significantly decreased in the agroforest. And that's consistent with some previous results, and it's inconsistent with others, particularly that De Huelvels et al. Study in 2014 from Costa Rica, because that study was done in the Talamanca region of Costa Rica in a cacao agroforest, which is right across the border in Costa Rica. So it's very applicable to the Bocas del Toro area that I was studying in. So it would make sense that I would find the same thing there if those regional effects are in play. It goes against others in Colombia and Mexico. However, perhaps not entirely, because the fact that there were some amphibians found in the agroforest suggests that they can be a habitat for certain species of amphibians. It is just a limited habitat for a limited number of species. And a likely reason for the difference observed between the agroforest and the natural forest is amphibian sensitivity to environmental change. Their particular biology makes them more vulnerable to changes in environment, which could prevent them from using agroforest even when other organisms such as birds or insects are able to. And because of that, these results place doubt on agroforestry's capacity to aid in amphibian conservation, simply because they cannot aid as much as a natural forest. But there is evidence that it can play a role in amphibian conservation, because agroforests don't have to be natural forests to have conservation value. When put in place of traditional monocultures, we see that it's going to hold more biodiversity. So it can play a role here, but it's certainly not going to be playing a role if we're expanding it into natural forest. And it's certainly going to be limited to only certain species. Moving forward, the best course of action here is going to be protecting natural forest for amphibian conservation, and particularly protected areas. Of the 13 species observed in this study, all 13 are of least concern by the IUCN, and both of these study sites are in human-dominated landscapes. So in order to protect our most vulnerable amphibians, that suggests that the best course of action is to protect the environment away from that influence in protected areas like nearby Pila. And there are some limitations to this study. This survey mainly only looked at terrestrial amphibians. The survey method doesn't include a way to measure canopy, amphibians, tree frogs, or fossorial species as well. So the conclusion should be limited mainly to these terrestrial amphibians. And the survey was also done in the dry season. It would have been much better to do it both in the dry season and the rainy season, but obviously for reasons based on time, we were limited to doing it in the dry season. There's some known error here as well. Dendrobates auratus was found in the natural forest. I lied. But it was found outside of a transect after we were already done and packing up. So it was obviously not technically observed in that environment. However, we know that's an error. But considering the amount of trips we took to the natural forest, to only see it one time out of a transect suggests that it's incredibly rare in that environment and that it's not going to be significantly affecting our results in any way. There's also the potential for potential error. Agalicnus calidrius, which is the famous red-eyed tree frog, was found on the property, but never in a transect, and that's because it's a canopy species, it inhabits the canopy, and we're obviously not going to be able to identify it and see it. So there's, of course, the potential for unidentified amphibians to be present in all of the transects. But because of our survey methods and consistency in both environments, that's not going to bias one environment over the other, and it brings us back to that first point that you just limit the results to the terrestrial amphibians that we were looking at. And I want to reiterate that discussing these limitations should not detract from the significance of these results. They are incredibly significant and they're incredibly clear. And the main conclusion, the first one right away, agroforests are not a substitute for natural forests, at least for terrestrial amphibians and Bocas del Toro. That's pretty clear by all the measurements in diversity and abundance. However, they can still have some conservation value because they were shown to hold some amphibian species. But it's much more important to protect our natural forests and, if possible, create or expand more protected areas, especially if we're aiming to protect amphibians in particular. This, though, remains a topic in need of much more research here in Panama and around the world. There's not a lot of study here, which is really surprising considering the importance of this type of research. I'd encourage more study around the world to test how it can work in every area, but also specifically here in Panama. At the study site, I'd love for a repeated survey in the rainy season. I would love for surveys on the farm that look at auditory surveys or stream transects or passive or active traps, although you need a permit for that. All of those to get a census of the entire amphibian community and not mainly the terrestrial ones. Some of the studies that have been done on that are here in the references, and I would like to now open up the floor for questions. Puedo contestar en español, como quieran. Eva.
Yeah, you mentioned that amphibians are particularly vulnerable to evaporation. I feel like that's something we talked about with Edgardo, but I can't really remember why that is themselves.
Well, they're dependent on aquatic and terrestrial environments as well, which means they're both dependent on the cleanliness of the terrestrial environment, but they're also dependent on the cleanliness of the water. Also, because of their intake of water, they're more susceptible to waterborne pollutions. And one thing noticeable in the agroforest here is that there's not a consistent source of water. It can puddle up and form pools after strong rains, but other than that, there's not a source of water here. And there is a creek in the natural forest that provides a more consistent source of water. So that's obviously a source of environmental management style, a change there that could affect them. But it's, in terms of their particular biology, it's the dependency on water and terrestrial habitats. Megan.
How many transects would you end up doing in a day?
It depended. So initially I planned for a nice even 2 a day, And a couple rainstorms later, I figured out that was not going to be possible. So it was what we could actually do. Some days we would knock out 5 transects because it would have been raining for like 2 days before that. Other days we would do 3, maybe 4. I'd say on average we did 4. Jessica.
Have you taken the presence of the creek into account when you're looking at your results and the differences between the areas?
Yeah, that's certainly a possibility. The creek does border one part of the agroforest. Let's go back to the map. Down where the line is fairly flat in the agroforest, there's a creek as well. It certainly could be affecting the results as well, but we did not place any of our transects at or next to the stream. We intentionally kept it away from the stream, partly because next to the stream made it pretty unfeasible to place a transect, and also partly because this was an attempt to avoid that kind of bias as well. Bonnie.
I have 2 questions. Who is we?
When I say we, I'm talking about Antonio and I. Antonio is my guide, he's Orlando's son, and we did all the transects together. He introduced me to some very friendly fer de lance. It was awesome. John. There certainly could be. If you see that area where they're closest over there, there's a road in between there. That's where we walked down to go to the agroforest when we visited. So there could be, certainly, but if so, it would be only frogs that are intending to stay in the agroforest, which, I mean, that's not going to be biasing results. That's what we want. We want to know who's inhabiting. Could be some interchange. And Bonnie, back to you.
When you were looking at the species distributions, you took the total abundance of species, correct? Like the total counts, not an average.
For which one?
The species distributions of,
Yes, this is total observed. See, here 156 total, 30 total.
okay. And then which one did you take averages for?
All of these, average per transect.
And then one more question. For the species distributions, you said you did t-tests, but did you do like ANOVA for the like individual species to see which species, like in particular, varied from each other?
No, I didn't compare species between each other. I compared species between environments. Oh, that's too far. Any more questions, Wade?
Is there any information on the specific differences between an agroforestry environment and a non-forestry environment that is causing the decrease in?
There is, but it's case dependent because it's also management dependent. How you manage an agroforest can greatly affect how the agroforest works in an environment, particularly if you're applying chemicals. That kind of throws out the window its ability to function as a conservation hotspot or center. But because of that, in particular, at this study site, you'd need to measure those differences. Some of those I could think of now. That'd be a great idea for a next study to compare those. You could look at canopy cover or percentage cover of small plants and logs, all kinds of those sorts of measurements. I think that would be of good value for us. We had our hands full working with these amphibians, so we didn't add that to the study as well. Ali.
Really good job. I have a question. You mentioned in your introduction that that there are these studies that don't support the use of agroforests as habitat, sufficient habitat as much as forests do. And I kind of got hooked on the use of your word as sufficient or enough. And I'm wondering, as we think about conservation and we think about the role of agroforestry, as you know, is very dear to my heart, what is in fact enough? Because here you what is in the context of, if we're talking about a typical agricultural field, on the one hand, and then also in terms of, could you visualize, this is kind of another question, looking at comparing carbon capture, adding that as a variable into carbon capture in agroforest versus forest, how that would work. So there's a lot of questions in there. Feel free to answer.
Yes. Profesor Marcenet, can you encender la presentación otra vez? Gracias. Awesome. But for that, personally, for me, what I think would be sufficient is that 60% mark and up. What you can hit for those other organisms, which I don't want to discredit this agroforest. I can personally attest to the amount of insects, birds, and reptiles specifically. The amount of lizards we saw while doing transects was ridiculous. So it's working incredibly well for these other species. These results just suggest that it might not be enough for amphibians. And I think that 60% or up is what I would target. But like I said, they do still have value because I'm sure the values, and this would be another opportunity to expand the research, and the banana monocultures would be practically nothing. So I really hope that these results don't kind of cloud your judgment about these agroforests. They are still incredibly resourceful ways to manage not just our biodiversity conservation needs, but also our socioeconomic needs of the community. And especially that carbon capture thing, that's another area for research. If you could compare looking just overall, not just at the biodiversity conservation, but compare the carbon capture, the local economy that it provides, and the biodiversity conservation, to compare it to monocultures and natural forests to see which reigns supreme in all of those categories, I'm sure agricultural, agroforestry would have a significant chance of being at the top of that list. Here's some of the frog friends. All right.
Hola. Buenos días, autoridades de la Universidad Tecnológica de Panamá, doctora Alison Dagan, doctor Eric Manzané, compañeros, público presente. El día de hoy les estaré hablando sobre mi investigación que lleva por título Evaluación de fincas agroforestales en Los Santos como sistema de compensación forestal de la construcción del puente atlántico de Panamá. A manera de introducción, es necesario conocer que los bosques en el mundo brindan importantes recursos, como son el control del clima, la degradación de los bosques, está también la degradación de los suelos y los bosques tropicales se caracterizan por ser zonas de vida que se desarrollan bajo diferentes condiciones. Esas condiciones son como la altitud, temperatura máxima de 18 grados, temperaturas mínimas de 18 grados Celsius, precipitación entre 500 y 2000 milímetros, y también presentan algunos estacionalidad marcada o estacionalidad casi ausente. Las extensiones de los bosques tropicales se han visto afectadas actualmente por los países que se encuentran en desarrollo, ya que estos buscan priorizar lo que es la urbanización y la construcción de infraestructuras en áreas previamente boscosas. El desarrollo de estos proyectos genera una serie de impactos que se harán visibles con el pasar de los años, aumentando lo que es la deforestación, la extensión de los cultivos ilegales, la degradación de los bosques y la reducción de la capacidad de dióxido de carbono. Para esto se desarrollan lo que son las compensaciones forestales, que son consideradas como una herramienta que busca subsanar lo que son las medidas socioambientales, y esto generado por los proyectos, provocando que se mantenga lo que es el equilibrio entre el ambiente y los ecosistemas. Las zonas de vida que fueron afectadas por este proyecto son dos, que son el bosque húmedo tropical, que es la zona más extensa que se encuentra en el país. En él encontramos árboles de aproximadamente 35 metros. Entre las especies que se encuentran aquí están el Terminalia amazonia, el Anacardium excelsium, el Ficus, entre otros. También la otra zona de vida impactada fue el bosque húmedo premontano, que este es un bosque donde se encuentran especies semideciduas, y también hay lo que son especies de mediana altura, y esto hace como que se desarrolle lo que es más el sotobosque debajo de ellas. En este encontramos especies como el Terminalia amazonia, el Anacardium excelsium, el Tabebuia crisanta, entre otros. En Panamá, para el desarrollo de los proyectos se debe permitir lo que es un estudio de impacto ambiental, que es regulado por la ley número 41 de 1998, llamada también la Ley General del Ambiente. En este estudio de impacto ambiental presentado por la empresa Puente Atlántico, es un estudio de impacto ambiental categoría 3, que tiene un área de influencia de 517.982 hectáreas, que se dividen entre áreas de influencia directa y áreas de influencia indirecta. En estas áreas se totaliza lo que son las áreas con bosques maduros, bosques jóvenes, los manglares, y también están las áreas con urbanización y con suelos sin nada. La realización de estos proyectos, de estos estudios de impacto ambiental categoría 3, hacen que se tenga que realizar lo que son las medidas de compensación y mitigación cuando se finaliza el proyecto. Esto se debe seguir mediante el Manual de Compensación Ambiental establecido por el Ministerio de Ambiente. Estos proyectos tienen el objetivo de que en este proyecto se tenía que presentar lo que son, cada semestre se tenía que presentar cómo iba evaluándose el proyecto en la construcción del puente. Y al finalizar este proyecto se presentó que se deben reforestar como compensación 64.99 hectáreas en 5 años, donde se le va a dar seguimiento y mantenimiento. Mediante la resolución que está allí, se establece cuáles son las especies que van a ser sembradas. Las especies van a ser maderables, frutales y de café, que fueron aplicadas en un sistema agroforestal. Este sistema agroforestal fue establecido en la península de Azuero, entre la provincia de Herrera y Los Santos, principalmente en la cuenca del río La Villa, entre los ríos Gato y Estivana. Y para mi proyecto, mi principal área de estudio es la provincia de Los Santos, en el distrito de Macaracas, donde se estableció al final un total de 20.4 hectáreas en la que participaron 30 productores. Pero al principio de este proyecto participaron 35 productores, sin embargo las condiciones que presenta el clima en la región hicieron que estos desistieran de esto y al final solamente contaran con 30 productores. de esto me surgió la siguiente pregunta de investigación, y es cómo funciona la compensación forestal establecida en la provincia de Los Santos referente a los impactos, a los daños ambientales causados por la construcción del tercer puente. Como objetivo tenía lo que era evaluar si la biodiversidad perdida es realmente restaurada por parte de las compensaciones forestales. Para esto realicé la siguiente metodología, que fue primero realizar una revisión de literatura sobre cómo funcionan las compensaciones forestales a nivel mundial y a nivel nacional. Seguidamente hice una revisión del estudio de impacto ambiental de la construcción del puente, donde busqué principalmente lo que es el inventario forestal de todas las especies que fueron taladas durante ese proyecto. Después hice la visita a 6 fincas que se encuentran dentro de este proyecto de compensación forestal, las cuales se encuentran entre Bahía Honda y Quema. Ambas forman parte de lo que es la división política de Macaracas, y también en esta lo que hice fue identificar cuáles eran las especies que se encontraban en cada una de las fincas. Estas fincas eran total 30, pero yo escogí 6 porque las 6 presentaban supuestamente características diferentes en lo que es el informe final de reforestación. Luego hice la evaluación del índice de biodiversidad de Shannon entre las fincas agroforestales y el área impactada durante la construcción del puente. Para esto obtuve los siguientes resultados. Está en las éticas. Se visitó las fincas agroforestales, donde tuve que interactuar con lo que son los dueños de estas, y tal vez quizás no les agradaba tanto de que yo entrara a su finca y que diera a conocer cómo está funcionando esto. Y también tuve que visitar el Ministerio de Ambiente en la sede de las tablas, donde se me presentó el informe, donde estaba todo supuestamente redactado, y también encontré incongruencias, y quizás eso puede ser que no les gustara tanto. Están, ahora sí, mis resultados. Al visitar en el sitio encontré un total de 21 especies que van entre leñosas y herbáceas, y siendo la principal que se encontraba en las 6 fincas fue el café robusta o Coffea canephora y el caoba, que es el Swietenia macrophylla. Y también encontré especies frutales. De las 21, 15 son parte de las especies frutales, entre las cuales se destaca obviamente el café robusta, seguidamente del guanábano, el aguacate y el plátano macho. También hice una caracterización para lo que son las especies maderables, las especies de importancia en la industria forestal panameña, y se encontraron 5, que son el Swietenia macrophylla, el Tabebuia rosea, el Dalbergia retusa, el Cedrelo dorata, el Esterculia petala y el Tabebuia guayacán. Entre estas 5 están una que está prohibida su tala en el país, que es el Dalbergia retusa. Y al hacer mi índice de Shannon, obtuve de que hay una disminución en cuanto a comparar lo que es el sistema agroforestal con el área del puente sobre el canal en el sector atlántico. Y mi discusión es que la compensación fue establecida en 65 hectáreas. Estas 65 hectáreas se realizaron análisis de suelo previamente para establecer cuáles eran las especies aptas para ese sitio. Sin embargo, hubo una tasa de mortalidad del 60% al principio, lo que indica de que quizás solamente estaban evaluando cómo funciona el suelo y no cuáles son las condiciones climáticas de ese sitio para que las especies sean aptas. En este sistema de compensación, una de las principales iniciativas es que los productores generaran ganancias a partir de la implementación de estas plantaciones. Sin embargo, cuando yo fui y las 6 fincas que visité, lo que encontré era de que las especies de café robusta se estaban muriendo, y las de café que estaban supuestamente produciendo, solamente una finca había logrado obtener lo que son 10 libras de café. Eso no cuenta como una ganancia para los productores. Los índices de biodiversidad de las especies presentan una disminución en la compensación forestal con respecto al área afectada por el proyecto, debido a que el proyecto forma parte de un bosque y en la compensación estamos implementando algunas especies, no estamos estableciendo el total. En esto en el inventario que se presentó por parte del canal, habían 109 especies que fueron taladas y solamente me estás diciendo que estás compensando con 21 especies. Y esto quiere decir que el sistema de compensación en Panamá no está funcionando de manera relativa de mantener el equilibrio entre lo que es la pérdida y la ganancia. No estamos manteniendo el equilibrio de la biodiversidad perdida y la biodiversidad ganada. También de que por parte del Plan Nacional de Reforestación Forestal que se tiene aquí en Panamá, hay una parte que dice que las compensaciones van a contar como reforestación. Sin embargo, no podemos contar como reforestación algo que está tratando de suplantar un proyecto que está dañando otra parte del bosque. No puede ser considerada de esta manera. Y como conclusiones, existen fallos en cuanto al balance de los servicios ecosistémicos que son perjudicados y la diversidad de especies en la compensación forestal. Las especies que son utilizadas demuestran que hay una pérdida de biodiversidad en los sistemas de compensación forestal con respecto a los bosques afectados. Se deben realizar reformas a lo que es el manual de compensación, ya que este también presenta incongruencias, y también de que el seguimiento de compensación en 5 años no tiene sentido de que tú entregues un bosque supuestamente ya compensado en 5 años. El crecimiento poblacional ejerce mayor presión sobre las áreas boscosas debido a la urbanización. Sin embargo, no tenemos que olvidarnos de que se debe velar por la conservación en la medida de lo posible. También que el tiempo que se da para lo que es el seguimiento y el mantenimiento no garantiza de que tú vas a tener un bosque al final de los 5 años, y tampoco estás velando porque las especies en la temporada seca estén estén en un sistema, tengan un sistema de riego o algo así que permita que éstas sigan viviendo. Y bueno, mis referencias. Gracias por su atención. Y bueno, como conocimientos que obtuve de este proyecto, en realidad tenía muy pocos conocimientos sobre lo que eran las compensaciones forestales, y al investigar sobre esto me doy cuenta de que existen fallas en lo que es las leyes que hay aquí en nuestro país, de que nosotros como estudiantes debemos reformar todas estas cosas que estamos viendo, actualmente estamos viendo que están mal, y debemos actuar ya, porque si dejamos esto para más, ya no vamos a tener que compensar si ya no tenemos nada. Y muchas gracias. ¿Preguntas?
Magnífico. O sea, expusiste un problema que es actual, latente, existente y que viene de arrastre de muchos años. La pregunta de esto de la compensación es, oye, ¿a qué parámetros entonces se agarra la compensación para poder, valga la redundancia, compensar el daño que se ha hecho en un lugar y trasladar esa compensación a otro lugar que tal vez geográficamente no tiene las mismas condiciones? ¿Qué parámetros usan en la ley? Si me puedes...
Hay lo que es lo que se le conoce como Manual de Compensación Ambiental, que es establecido, es un documento que te da el Ministerio de Ambiente, donde te dan una fórmula y tú metes allí un pocotón de hectáreas que tú supuestamente dañaste, que no dañaste y cosas así, y al final te da un resultado y tú dices que tú vas a reforestar 64.99 hectáreas. Sí, sí. O sea, no tienes una zona de vida específica a la que tú debes reforestar. Porque el sistema de compensación en realidad iba a ser solamente de café, y por parte del Ministerio de Ambiente decidieron implementar lo que son especies maderables y frutales.
O sea, tristemente hay una incompetencia muy grande, especialmente porque el café es una especie foránea, exótica, ¿sí? Claramente si no tienes agua
suelo, no va a ser rentable. ¿Sí? Por más que sea robusto, que robusto es un café de bajura, como le llaman usualmente los cafeteros, de montañas bajas. ¿Sí? Y sencillamente, ¿qué te puedo decir? Estamos mal.
¿Sí?
Gracias, Julie. Hiciste muy bien. Si mal no recuerdo, tú te enganchaste con esta idea porque habías ido a visitar.
Sí. O sea. Okay.
Creo que muy amablemente te habían ofrecido una oportunidad. Entonces mi pregunta es, ahora que hiciste tu trabajo, si nos puedes contar un poco el antes de y el después de.
Bueno, al principio yo fui a preguntar porque mi proyecto iba a ser enfocado en fincas agroforestales y cómo se desarrollaban estas, pero cuando fui al Ministerio de Ambiente en las tablas me dijeron que no hay fincas agroforestales en Los Santos y que lo único que hay son fincas silviculturales, pero que estas también tienen problemas porque la gente le mete las vacas cuando están en desarrollo y hay pérdidas y eso. Y me mencionaron lo que fue la compensación esta, y después yo me puse a hablar con el profesor Eric Manzané, que es mi asesor, y de allí nos surgió la pregunta de cómo funcionan las fincas agroforestales como compensación. ¿Y cuál era su pregunta? Ah.
¿Qué has realizado? O sea, te fuiste con la idea que ellos te ofrecieron y ahora que hiciste trabajo.
Bueno, ellos cuando yo fui la primera vez me mostraron el documento, pero solamente fue como que, mira, tenemos este documento, pero ya la segunda vez cuando fui sí me lo prestaron y pude tomarle fotos, fue como normal. Lo que sí me preocupaba era cuando fui a las fincas agroforestales porque pensé como que a los señores no les iba a gustar de que yo fuera al sitio y esas cosas. También hay algo que se me olvidó mencionar y es que se habla de seguimiento y mantenimiento. Y una de las fincas, de las últimas fincas donde yo fui, que eran como las que estaban más lejos, me dice el señor que solamente sembraron y más nunca fueron. Entonces, allí queda como, ¿y el seguimiento y el mantenimiento? Usted tenía una pregunta.
Sí, Lisa, muy interesante el trabajo que existe. Y la pregunta que te iba a hacer es que ya se te hizo una reacción de la gente.
Sí.
Nosotros somos de allá y yo conozco y el daño económico que han hecho es tremendo y yo siento que la gente no crea conciencia del ajuste del cambio climático que tenemos nosotros en Azuero particularmente. Yo conozco el área y por lo que vi en la presentación, más o menos por esas áreas tú estuviste, lo que es el área de Canajagua, el cerro Canajagua, la falda, eso era antes. Yo recuerdo pequeño que había plantaciones de café. Sin embargo, hoy día eso se ha perdido, totalmente se ha perdido. O sea, nadie le da seguimiento. La destrucción de los bosques es tremenda. Entonces yo creo que tú tienes un trabajo grande que hacer allá en la
hay algo que tengo unas imágenes, no sé si puede echar para atrás. Tengo unas imágenes de cómo se veían las fincas en la discusión. Allí está, por ejemplo, hay 3 imágenes. La primera es la primera finca que visité. Podemos ver de que hay ciertos árboles allí. La segunda era cómo estaban las plantas, las hojas de los cafés. Y la tercera es la última finca. La tercera, no puedo mover. La tercera es esta y es cómo está la última finca. En realidad lo que más tenía esa finca era plátano y por acá casi llegando a la casita tenía lo que eran como unas matitas así de limón.
Una pregunta, ¿y para eso tuvieron que darle plantones y lo demás, eso de dónde lo sacaron?
Los plantones fueron traídos de viveros que se encuentran precisamente por el cacao donde vive Catherine. De allá supuestamente fueron traídas las plántulas y supuestamente venían con cosas adaptadas a esto del clima y esas cosas, de que no traían plagas, no traían nada, pero en realidad hay café, supuestamente cuando yo caminé por aquí, hay café, pero podemos ver de que como lo exige su desarrollo, pierden todas sus hojas y no tienen ni siquiera fruto ni nada, y supuestamente en la otra finca ya tenían frutos. En la finca donde había sombra, pero la sombra era de un árbol de mango que tenía más tiempo de estar ahí, y por eso habían cosechado sus 10 libras de café. Ah, sí, profe.
Después de todo el trabajo realizado, ¿ves tú posibilidad de continuar en este tema tu trabajo final o tu trabajo de grado?
Sí.
¿Crees que por allí pudiera ser tu aporte en investigación? O sea, ya ahí sí, ya comenzaste, ¿no? Ya descubriste muchas cosas y te diste cuenta en el camino que a pesar de que sí hay algo escrito por allí, no es lo suficientemente robusto para dar respuesta a toda esta problemática. ¿Crees tú que pudieras contribuir en eso, a mejorar esos instrumentos que existen actualmente?
Claro que sí. Sí.
Me gusta mucho pues que hayas podido integrar el curso a tu área, a la parte forestal, y que se ve que pues hay muchas cosas que puedes contribuir en diferentes temas, ¿no? A ella te va a tocar un poquito más estudiar, investigar un poquito más, y la parte que has comentado que es la difícil, ¿no? Cómo llegarle a las comunidades, cómo llegarle incluso a las instituciones, porque no es sencillo cuando tú le quieres decir a alguien hay algo que no está bien, a las personas eso como que no les gusta, y sobre todo si viene de un estudiante, porque dirán, no, pero si nosotros tenemos 50, 100 años en este tema y siempre ha funcionado así y está bien. Ese es el cambio de paradigma que ustedes tienen que hacer, ¿no? Llegar, y cómo llegar a ellos, no diciéndoles que están equivocados, sino dándoles más bien una opción de mejora, una oportunidad de mejora en función de lo que se ve, ¿no? en las comunidades, y que esto no hay que ser un erudito en el tema para darse cuenta que la compensación no está funcionando, o sea que eso no está dando respuesta al daño que se está haciendo ecológico, como decía acá en la pregunta. Es como si dañaras aquí, pero vas a sembrar, yo qué sé,
café
por allá en Argentina, y papo, sí, pero tumbas todo este bosque. Entonces, la respuesta como que
no hay
está,
sentido.
¿verdad?, de la mano con el daño que se está causando. Así que, bueno, tienes tarea. Tienes tarea. Muy bien, te felicito.
Gracias.
Oh, receso. Menos mal. Oh God, I feel my heart in my chest. No, I'm so nervous for this one. y'all. Wait a second. Oops. ¿Está bien? Lago, can I use your thing? Okay, I'm gonna start. You guys feel free to take your time though. I am here to present a project recently finished called Species Distribution and Estimated Biomass. This was an assessment of the mangroves at 3 different distances and sites behind Playa Estrella and Isla Colón. Like I said, this is my independent study project, guided by my lovely advisor here, Gabrielle. So an outline for this presentation is going to include just an introduction on mangroves, their biomass, a site description, some research questions and goals that I had, a methodology for estimating biomass, general allometric equations that were used in my methodology, results, discussion, a conclusion, some acknowledgements and a personal reflection, and then my references. So just to introduce this topic, I know we all have some ideas, but the ecosystem services of mangroves run far and wide. They're coastline protection, raw materials and food for humans and for fish and other organisms. They act as erosion control, water purification systems, maintenance of fisheries, tourism, recreation, education, research, and carbon sequestration. I highlighted these because this is kind of what revolves more around my specific study and what I looked at. But yes, there are many, many ecosystem services for mangroves. They're very important ecosystems, which we're going to kind of look at more. One of those kind of bigger ones in the terms of global climate change and the global value on mangroves is the carbon sequestration. Their carbon cycle dynamics include producing and burying extremely large quantities of carbon, much larger than any other forest ecosystem on the planet, and a 30 to 50% aerial decline of the mangrove ecosystems due to land clearing and aquaculture expansion, overharvesting, eutrophication, and development prompts estimates that mangroves may functionally disappear in as little as 100 years. And I just want to put that out there because they're very important ecosystems, as we can see here. I would just, how do I go back? No. So just to kind of focus in more on what I was looking at is the biomass in the mangroves. Their above ground biomass, their kind of carbon is pooled in 5 places in the mangrove ecosystems: above ground biomass, below ground biomass, leaf litter, deadwood, and soil carbon stock. I looked at above ground biomass and below ground biomass in the mangroves behind Playa Estrella, although the other parts of biomass are still very, very important, including the soil carbon stock. The soil is called peat. It's an accumulation of hundreds of thousands of years of decomposing plants and decomposing leaf litter, and this is where a lot more than majority of the carbon is stored in this below ground biomass and in the soil. These complex roots in the vegetation of below ground biomass allows for these coastal wetlands to trap mineral sediments and the organic matter, leading to these higher rates of carbon sequestration and just more productive soil. And the high nutrient qualities of these ecosystems is a guiding force in the interchange of matter and energy between the ecosystems of seagrasses, corals, mangroves, all working together in a highly productive environment. And in terms of what the comment that I made before about the 50% or how much was it? The 20 to 50% aerial decline of these mangroves. When the peat comes in contact with oxygen, this high quantity of carbon combines with the oxygen, and that's what releases all of this carbon into the atmosphere, which is why it's really important to protect these ecosystems from deforestation and other human impacts, which I'm also going to be looking at this study that came up as I got to Playa Estrella and started observing what was going on there. But yeah, it's just a product of degradation and human impact when this really, really high productive soil meets oxygen. So for my site description, I went to Playa Estrella, Isla Colón, in Bocas del Toro. I stayed in Bocas del Drago, which is just on the other side. As you can see here, this is a picture of Starfish Beach in 2002. And this was before, basically in 1993, the zone of tourism of Panama declared Bocas del Toro this really high interest place of tourism. They were trying to, They were trying to advertise it as this beautiful Caribbean place to go to, and that started in 1993. But after 2002, the Instituto Panameño de Turismo aggressively marketed Bocas as their finest example of ecotourism. And just following a global trend of sun and sand tourism, it started to become really, really popular. And so as you can see here, maybe it's kind of poor quality, but there's many other buildings that have been built since 2002. And this is an older image. But now this is in 2020, pre-COVID actually, and you can see there's many restaurants. And actually, as I went there and started to do my field work, there's many, many restaurants underneath the tree canopy cover that you cannot see looking at satellite images. So that made for a more interesting project in the field. There was a lot going on. These were my 3 sites. These are my 3 transects. I set up 140-meter transects. I'll go more into my methodology. This is also another aerial image of Playa Estrella in 2002, before this extreme wave of people came to Bocas to experience the sand and the beauty. So yeah, in the Bocas del Toro archipelago, there's 2,885 kilometers of mangroves, and those are half of the mangroves on the Caribbean coast of Panama. It's a very high concentrated area of mangroves, mostly dominated by Rhizophora mangle, but other species like Lagunculario, Racemosa, and Avicennia germinans are present as seen in my study site. So my research question became, how does average above and below ground biomass per hectare of the mangroves change at 3 sites and distances behind Playa Estrella, Isla Colón? And is human presence impacting the mangroves? This part for me was a really impactful part of the project because, like I said, the field work, I went in kind of expecting one thing, and I will show to you guys that I left with something else. So it was really interesting, and I'm very grateful. But regardless, my goals of the study were to calculate the average biomass per site and species along Playa Estrella. I started at the fringe and then headed farther into the mangrove wetlands. I wanted to assess the species demographics and the distribution of different individuals to kind of understand how the biomass is changing. My methodology, I used a non-destructive radial quadrat sampling technique. It's a long phrase. Transects were set up at 3 different sites along the beach, although in the end I was really comparing distance. I used that the first 40 meters was like my close. I skipped 10 meters, and then I did another 40 meters. I skipped another, and then I did another 40 meters. So in total, there were 36 quadrats. Like I said, I started 5 meters from the end of the beach, going into the fringes. And I measured the diameter at breast height and at 1.3 meters of height on all plants that were above 3 centimeters. I also took notes on the number of individual species and then the general observations of the area. These were my general allometric equations that I used for my study. Like I said, I found 2 species in this area, the Laguncularia and the Rhizophora. These are species-specific equations to try and make the biomass estimate as specific as possible. I used wood density calculations from the Agroforestry department. Basically, these are pretty species-specific, and so I applied those into a below-ground biomass estimate along with a diameter at breast height. I also calculated carbon content although it's not, the data is not included in this presentation, it's just the ratio is the same. And so basically, it's very similar to the calculations of total biomass. So for species distribution, these are my results that I got. I'm going to look at sites and then the distances, and then I'm also going to look at species-specific biomass and biomass per site. So this is looking at the number of individuals at 3 sites and then the DBHs of the individuals per sites. And so in total, across all 3 sites, there were 347 individuals. 44% of them were Laguncularia, and the other 56 were the Rhizophora manglae. Site 1 had 163 individuals and an average DBH of 12.45. Site 2 had 112 individuals and a roughly similar average of DBH, 11.95. And Site 3 had less individuals, 72 individuals, with an average of 12.59. So there was no significance between the differences in the DBH, and there was actually no significance in the number of individuals at the 3 sites. But as you can see, the interesting part about the species distribution is that where there's a really high quantity of Laguncularia, there's less of the Rhizophora, and that is kind of a trend that you're going to see also within distances, that less of one species means more of the other, which was quite an interesting find in this study. Also, looking at the distances between the close, medium, and far, you see a similar trend where there was a lot of Laguncularia, there's less red, and so forth, kind of this inverse relationship. Looking at the DBH of these individuals closest and farthest to the beach, and also the distances, the farthest quadrant had 26 more individuals, but there was no statistical significance between the total number of individuals or the individuals at each site. There was also no statistical significance between the DBH, but this is really interesting because that means that between the sites there was no, you can't look at it and be like, oh, there was no statistical significance because of my other results. Sorry, that was not very clear. I'm going to explain it in a second. But yeah, so there was no statistical significance between the averages, although the DBHs in the farther quadrant were highly concentrated in smaller numbers. Sorry, I'll explain why that makes more sense in a second. But yeah, so then we looked at the average and above and below ground biomass per species and the diversity index of the species in all 3 plots. And there was very low biodiversity, which would make sense because there were only 2 species. And there was no significance between the above and below ground biomass. So then we looked at average biomass per site of Playa Estrella, and per site it didn't differ as much either. There was, again, no statistical significance between above and below ground biomass or biomass per site. Site 2 had the lowest average biomass, and Site 3 had the highest, but as you saw, the distribution of species and the lack of significance between the above and below ground biomass would not indicate that one species is playing to more biomass or another species is adding to more biomass either. It was just, that was the distribution. Where I did find significance, though, was in the distances. And again, like I said, and was trying to explain more clearly before, that the lack of statistical significance between individuals per distance and the lack of statistical significance between the DBH indicates that those are not contributing factors to why the biomass is so small. Instead, I found significance basically between the medium and the far and the close and the far. As you can see here, that the farthest quadrants had the lowest biomass. And you can see that in the averages as well. And so then why these results are interesting are because of my field observations, where in the close quadrants I found so much trash and so much pollution, and although there was no statistical significance between the close and the medium plots, trash was found in the first 90 meters of the mangroves, and sometimes even farther, maybe 110 meters. But I found trash. This was trash dumping right when you walk in, maybe 10 meters. There were many small rhizophora plants that were not included in my biomass study because they were less than 3 centimeters. But you can't see it very well, but these were all broken roots. These had all been broken off. And like I said, they were not included in my biomass study, but they were very valuable for my observations. I also just found a lot of deforestation of the larger Laguncularia. And moving down the beach and still in the closer quadrants, this was an area where there was a bathroom over here on the beach, and there were just pipes running back into the mangroves. And I'm walking around, and I walk through human feces, and I walk through trash, and I walk through all of these things that you wouldn't expect from our experience in the mangroves, which was alarming, of course. I found deforested Laguncularia, but they were smaller. So these ones also wouldn't have been in my biomass study, and crowded roots of the rhizophora. I also found, and this relates directly back to the significance of the change in biomass, is in the farthest quadrants, I ran across several trails in the mangroves. People were walking through them, doing things. It was interesting, but I was walking through, I was putting my transects in, and there was trails that had been deforested, as you can see here, roots just cut off, and larger plants cut down. Here's just like some example of, you can tell that somebody had just like come in with a little knife and taken off these plants. And those were just my field observations. So to discuss a little bit more clearly of what these results mean, like I had said, 56% of the plot was Rhizophora manglae and 44% was Laguncularia. There lacked significance between the biomass of the two species found, and there was displayed regular arrangements of the plants that are characteristics of mangroves. Like we saw the competition where there was high Laguncularia, there was less Rhizophora. The low Shannon diversity index is concurrent with the knowledge that Panama is only home to 4 common species, 2 of which were found in this study. So it would make sense. Other studies in Panama and Matumba Bay found that there was an average total biomass of 45.6 above ground biomass and 22.61, or that's the standard deviation, and then 95. My study found on average that the biomass was 31.38. The difference in biomass in these 2 studies could be attributed to many things. Disregarding the anthropogenic activities in the area, the change in biomass could be attributed to a smaller sample and the presence of only 1 species in the study. But regardless, the difference would estimate that Pleiastrea has overall smaller biomass. And then when comparing distances, the farthest quadrants, like I said, had a higher number of individuals with a smaller DBH that resulted in a significantly smaller biomass. But the farthest quadrant did have the highest incident of deforestation, which you can't necessarily attribute those 2 together, but as we will see, some studies, I'll go back to this one, some studies, where is it? Yeah, some studies in this area had looked at how when there is high stressors such as deforestation, then the plant's DBH tends to be smaller because there's a lack of the larger trees that are deforested, essentially. So I looked at that a little bit, although again, these observations were observations. In the closest quadrants, there are observations of the broken Rhizophora, and this was interesting to me and kind of prompted my urge for further research because mangrove roots are major components of peat accumulation. The plants observed were not included in my study of biomass, like I said, but the smaller plants were observed to be cut on several instances. The pollution, the studies done in polluted mangroves have concluded that excess nutrients impact the biogeochemical dynamics in the ecosystem, and that chemical and bacterial composition of soil differ in areas of anthropogenic activity. And there is, again, this emphasis on maintaining healthy nutrient cycling in peat because it is such an important factor of the carbon sequestration of mangroves. So my conclusion was that the goal was to estimate and compare the average biomass between species and between distances and the ratio of above ground and below ground. The data collection and analysis estimate that mangroves behind Playa Estrella is 5,262.17 tons of biomass. And the abundance of juvenile R. mangla in the farthest quadrants combined with smaller biomass and observations such as deforestation were all potential indicators of why the mangroves 140 meters back have significantly lower biomass. And a post-COVID world is predicted to see a massive boom in tourism. If there's no place and plan, I feel like the overflow of trash and human presence could really permanently impact the mangroves behind Playa Estrella. Even if my research doesn't indicate that necessarily the biomass is changing, there are many other factors, like I noted, the soil and the lack of when the nutrients are being taken out from this deforestation, from taking the roots. And so I hope that this study and the observations and assessments from my fieldwork can urge further research on the health of the juveniles and the soil in the mangroves closest to the beach. I'd like to thank my friends in Drago, Abby and Jess and Bonnie and Megan and Mia. They were all really supportive during this process. This is my first research ever, and I'm really grateful for the opportunity. I'm grateful to Gabrielle. I'm grateful to all my professors. And yeah, it was a really amazing time, definitely hard to see such a pristine ecosystem so treated poorly, but yeah, I hope that this can urge something to be done in the community. Those are my references. Oh, I'm sweating. Preguntas, chicos.